when you add on the 50, when you look at when you add on the renewables that we already have and that are increasing, the greenness of our electricity grid just, 25 years from now will be such that making iron using electricity will not only be cost effective, but almost the level of greenness as this technology, where you were going from 1,600 kilograms of CO2 per ton of iron to 71. That one's like 1,600 to 90. I mean, that's a really interesting technology. And it's at the same stage in its development and on the same time scale. Those of you that were here last year will recall Dr. Sadoway from MIT talked about that project. And the third one is in the sequestration field, using technologies to capture CO2 and sequester, bond with the CO2 into some other useful product. And the Missouri University of Science and Technology just published a report in the last Iron and Steel Technology magazine about how successful that's been, to where they can use steelmaking byproducts called slags, for those of you that are familiar with the process, as a means of capturing and retaining CO2, which can then be used in road beds and to make these big blocks that you see to make piers. Mm-hmm. And that's a technology we're hoping to test in the next 5 years. So that one's on a little shorter time scale. But those are our three main investments, and we have some other research technologies coming down the pike also that I think you'll see some announcements on before 2009. It's been a big commitment. Thank you.
Even though they're being developed at less prestigious universities than the University of Utah, right?
Yeah. We're all trying our best to contribute to this problem.
Right. Yes, Scott?
Sorry to keep asking questions, but what do you see as the role for labor in this new technology? Is it comparable to what it is today, or is it less or more efficient?
Boy, that's hard to say until you have all the kit and the gear out there. I mean, we run our plants really efficiently now. I mean, man hours per ton are well below 2 on average on the industry, and below 1 in lots of plants.
You're removing the coke making process, though.
Yeah, you're gonna. The iron making plant of the future is not going to have a coke plant or a sintering plant or a pelletizing plant. So you're gonna have, I guess by definition, less people, and of course the ability to automate is going to advance as computers get more powerful. But I guess I was trying to make the point we're pretty good now, but you are going to shut down a lot of unit operations. So I imagine there would be a smaller labor component.
It may not be, again, directly translatable, but again, mentioning the copper smelting, copper producing plants experience. When they used the traditional bath smelting process, Kennecott had about 2,500 people producing 300,000 tons per year. But now they have 700 or fewer after they switched to this flash smelting furnace. So they're, hopefully the flash process requires less manpower.
But at the end of the day, it's one of the things you have to do to maintain the competitiveness of steelmaking here. Otherwise, if we don't get there, and it's going to move elsewhere. So I think everybody understands that as well. I'm sorry, excuse me.
Yes, have you been collaborating with other countries to develop these new technologies?
Larry, you want to talk about the double AISI program?
This whole CO2 breakthrough program is a global effort. Okay, we have 3 or 4 research projects going on in North America, but in Europe, Asia, South America, and Australia, there are also big steel industry research projects going on that are taking different approaches to solving the issue of making iron without emitting CO2. And we get together twice a year to share progress. And so we're not making the same mistakes, in Europe that we're making here as the research advances. So this is really a global steel industry effort. I mean, this is an enormous problem. I mean, not problem, enormous task to completely change the steelmaking process. It's something that requires the kind of commitment, manpower, dollars, and innovation, you know, on a global effort. So it kind of gives you an idea of the magnitude of it. So the short answer is yes, there's a big international collaboration to address new technologies to reduce the CO2 footprint of our industry.
And I guess the goal is to figure out which ones are going to work most successfully, and that may or may not be the ones we're developing here.
Right.
I should also add that the public sector commitment to that effort is very different in different parts of the world. You know, a huge amount of resources in the EU, in Japan. We have a very positive collaborative relationship with the Department of Energy here, but on a much smaller scale in terms of public sector support for these projects. I think in other parts of the world, you know, we see on a magnitude of maybe 50 to 1 in terms of the amount of money pouring in there. Okay. Well, we thank you again for taking some time to be with us on this crummy day outside, and appreciate your questions, and happy to follow up any other information you might need. Thank you.